Hi all, I'm Elsa Pastor. I am Associate Professor at the Technical University of Catalunya, and I am the coordinator of the WUIVIEW project. For those of you who already don't know what the WUIVIEW project is, it is an European action funded by the European Civil Protection and Humanitarian Aid Operations Agency, the DG ECHO. And the aim of the WUIVIEW project has been to analyze the structure's vulnerability in case of wildfires and to develop standard methods to assess those vulnerabilities in our communities. As I mentioned last Wednesday, we've been performing fire experiments and a huge amount of simulations using CFD techniques. And now it's just about time to start disseminating and sharing our findings. And this is actually what this webinar series is about. It is about to share. It has to be on sharing the findings and the methods to the community which is interested in wildfires. So today we have our colleague David Caballero from the Pau Costa Foundation. David has more than 30 years of experience in wildfire-related topics, so it's kind of difficult to summarize his CV and his wealth of experience. But let me tell you that he works as an international freelance consultant and instructor on fire risk assessment. He has participated in more than 15 international research projects on forest fire risk assessment and mapping, decision support systems development, and risk assessment at the wildland urban interface, either as coordinator or as main researchers. And currently, David develops research activity on new technologies for numerical simulation and immersive visual environments for the assessment and awareness raising in the wildland urban interface. And this is actually the job that he has been developing in the WUIVIEW project. David will present us the concepts and methods for prevention planning at property level linked to the community level, which is actually what we have been developing in WUIVIEW. And he will talk, for instance, about the role of residential vegetation and other combustible elements that jeopardize communities in case of wildfires. So thanks, David, for being here today. David will give us a talk through a PowerPoint presentation, and that will be displayed just in a minute. And for those of you following the webinar, please write your questions, write your comments, and I'll make sure to include all those comments and questions through the Q&A session that will take place after David's presentation. So David, welcome to the session, and the floor is yours.
Thank you very much, Elsa. It's a big pleasure to be with you and your team and all the WUIVIEW Project Consortium and all the attendees of this webinar, second webinar of the WUIVIEW project. We have a limited time. I would try to summarize very quickly some of the findings that we have obtained in the WUIVIEW project in regard to the planning of the microscale of the property level and how it relates to the community level. For that, I will use a PowerPoint presentation. I will share my screen. I hope it is displayed properly. Well, the idea is that we are facing a new reality. This very 2020 campaign in California has shown us that the fires that we are facing are way beyond our capacity of protection and extinction. The same saw the past year in Australia, in which these unprecedented fire events are running and raging across our lands, our populated lands, and we have observed the extreme fire behavior where thousands of people have been displaced, hundreds of houses affected or destroyed. And of course, we have firefighters which response is completely and utterly overwhelmed. In this reality, we have a need of self-protection. We cannot expect that the firefighters will save our houses and protect us. As we saw in Paradise in 2018, a fire crossing a populated land and destroying thousands of houses, or in Martin, Greece, and we have this destruction in Europe. So again and again, we are looking at these fire events. We have extreme energy release in terms of the speed of or degree of destruction. And now the question is, what can I do as owner of a property, of a plot of land, to protect myself in the future and to protect the others? Because this is one of the main messages to set out in this webinar, that the protection against forest fires of a community is a common effort. It's not just from individuals, but every individual is summoned to this protection. That is true that the fire is hitting our populated areas. So we have to think about the metrics and a way of understanding which is the relationship between the different combinations of vegetation and houses, what we call the wildland urban interface patterns, and how it relates to how the fire is behaving itself when it hits the community. So we have to start reading the wildland urban interface landscape, but looking at these four components: the fuel continuity, how the fuel is in contact with the structures, which are the fighting and defensive strategies, and which is the prevention strategy in some of these types of wildland urban interface. That we have these scattered houses across the landscapes as we have presented here in Ibiza Island, in Balearic Island, which is quite difficult to defend every single house. So we have to think about some self-protection strategies or risk mitigation. When we have this intermix, we have a compound of houses and vegetation which intermingles more closely, but we have many more houses there. So in this case, it's more clear that what I do as owner of my plot is having a direct effect on the property of my neighbor, and it has an effect of the whole community. And the same happens when we have a clear, sharp interface between the urban areas and the forested areas, in which we have the community, and just in the fringe, in the very perimeter of the urban areas, when you have to take care of protecting the houses, while in the interior of the city or the urban area is more or less self-protected. That's true in our reality, because these houses are non-burnable. It is completely different to what we have in the United States, Canada, Australia, and South Africa, for example. So this is good for us as Europeans. We have this opportunity to create these non-burnable areas, and to use that as a way of protecting and creating patterns from the property level to the community level. It's something we are going to look at more in detail. And well, what we're trying to do is just to protect our communities and our properties from an incoming fire. But an incoming fire has many ways of approaching to our community. The first and more important is that we have to identify which is the type of impact we're expecting, whether it is high energetic head, or the flank, or the backfire, or the flank fire, or head flank fire. Why? Because, as I told you, the important thing is that the first houses that the fire is meeting in our community will be more affected than those which are in the interior. That is very true, given that our houses are not surrounded by vegetation, and it's very permeable to the path of the fire. As in this case, and we have the point 2, it is quite full of vegetation. So all the properties which are not prepared are including fuel inside this settlement. So the fire will pass through without any problem. While we have in the front, we have a more, let's say, urban-like area with less vegetation, but the fire will hit with more intensity. So we have to think about the protection and our strategy for the community. It's dealing exactly with the strategy of what we are doing in each of the properties and for which the fire will be visiting. So that's, I think that's a very important point of this presentation, is what we want to protect, how we will protect that. And on top of that, we have to think that our properties in the communities will be exposed not only to fires, but also to the smoke, which is as important. So the protection of our properties should consider as well the position within the topography and what that means in terms of smoke affection, smoke accumulation, and so. So the overall strategy for the protection of the community would be to create several barriers to the progression of the fire from the exterior to the interior, giving more importance to the perimeter, the fringe between the urban and the forest lands. That's the ideal case, but it's not true. Now the question is, which is the title of this presentation, which is the role of the properties? Why I'm talking about all these communities and what we are talking about the properties. And this is because, and this is a very important message, whatever I do in my property has an effect on the pattern of the whole community. So I have to, first of all, design the community and then go down to the property and transform my property according to this overall plan. Makes no sense that I make an effort to mitigate the risk while I'm it's having no effect because my property is inside the settlement. Well, in the other hand, if I have a property who has a lot of fuel and gives continuity, it's havoc in the whole community. So that's the important thing of the planning of the property itself. We need to know which is the fire that is approaching, how it is approaching, in which position my property is within the community, whether it's inside or in a urban area or a forested area, what I'm expecting, and then to proceed to the transformation of my property. We have to understand that the exterior of the community should be transformed as well, and its property as well should be part of the protection, more particularly the forest land and the forest fuels which are entering our property. We may not allow this integration of the forest vegetation into our properties, as we observe in many places across the Mediterranean basin, more particularly in the Balearic Islands, which is very common to let the vegetation enter inside our property and integrate our property within the whole field. This is by all means non-defensible space. The same happens with my property, where we do not do any management at all, more particularly when you have these non-developed lots. Non-developed lots which have all these strata of fuels, and very easily the fire would build up even inside the property. In the exterior, we have to take care about these defensible spaces for the first rank of properties, because they are firstly and mostly exposed to the incoming fire, even if the fire is low intensity, as you can see in this image. A low intensity. So the idea is to create this adapted, naturalized exterior by creating this mitigation of forest field, protecting the soil, providing more water availability for this vegetation surrounding the community, and improved accessibility to ground forces, improved water supplies for the firefighting. All these strategies are mostly focused to protect the properties in the very limits, in the margin of the community, which is why we have to combine these strategies from the exterior, perimeter, and interior. And we have provided several transformations, you can see, using livestock and use of prescribed burnings and burnings of the fuel, and transforming this exterior landscape into something which will provide a low intensity fire, including the agriculture lands and even the golf courses you can see here in Valencia. These are very, very common structures which are very favorable, very good for the protection of the first rank of a lot of houses. What happens in the perimeter is that it is this real interface between the forest land and the non-so forest land, because there are some forest land inside the communities. But we can see is that our property would, if there's no transformation of the exterior, the fire will come with all the energy, all the power impacting in our property. So the way we plan the limits property, the properties in the limit, in the very fringe of the community is extremely important. You can see here, this is a fire in Lucent, that the fire came with at very high intensity, hitting some flammable edges and creating or extending or increasing the energy release near the house. The house here, you can see that there's a separation, some walls, and all these buildings around the house, which is not burnable, makes the house to be somehow protected from the incoming fire. So these lots near to the forest lands are of special importance, and more particularly when you have all these separations, for example, when you have pools or something like that. So I insist that the walls and the separations are two very good strategies within our plot to separate or protect our houses from radiation. That does not mean that our house is protected. It's protected or more protected from the radiation. You can see here that some nearby fields affected the property, so we have to do something more. You can see some other examples of the first rank of plots of lands with houses receiving this direct impact, which more or less that our houses are quite well prepared for resistance. You can see here a high intensity fire coming, hitting the wall serves as a way of protecting the house. There's not too much vegetation surrounding the house, but even though there was a destruction, there was a very long flame length affecting the roof of the house and stream partially the house. So I insist that all the lots which are in the limit of the property have to be treated more particularly, even if we have this limit is not exterior to the of the community, but even the limits with forested land inside the settlement, as in this case we have this transition between the forested lands into the back part of the yard of the garden, and you can see a lot of fields on different type of vegetations which entail the flame from escalation from a low intensity to a high intensity fire, from a low intensity fire to a high intensity fires, particularly in the first rank of houses, which are the ones that I want to protect. Here I can bring you one example of this very year. I've observed this is very, very clear that it was a low intensity fire with some trees scorched. It was coming, it was a flank fire actually, and with a nice separation, but the fire managed to catch these very flammable green edges, start the propagation inside the settlement through these plots of lands, through these properties. And here you have an example of the importance of these properties in the vicinity of forested lands. You may not use these flammable species because you are propagating the fire inside. There were some embers, production and propagation inside of the community. And you can see here in the same fire, the fire was coming from the left flank, hitting an abandoned plot. It is an abandoned plot with lots of fine fuel, with the remains, vegetal remains and everything, creating locally a high intensity combustion for several minutes. Even if the fire was low intensity, this particular lot of this abandoned lot, which was occupied by non-residents, created a high flame length and providing these embers and propagation inside the community. And this is more or less what you can see inside. So the first lesson learned is that these plots in the vicinity of forested lands should be managed as part of the protection of the whole community. Here you have another example, exactly the same. You can see it's very popular in Europe to have these second residence houses surrounded by these flammable green edges, but with forested lands inside the garden. In this case, this vegetation is exactly the same as this vegetation with cured grass, very flammable species here and there, plus the extra of the flammable green edges, creating this low intensity fire to be a problem in the nearby houses and properties. So you can see that the management of this type of gardens should be taken more in detail than the others. Another point that we were discussing within the WUIVIEW project is not only this fact of the green edges in the border, but as well the positive aspect of the vegetation, more particularly how when we are removing vegetation, we are changing all the aerodynamics of it. And more particularly, we made some different examples of creating these perimeter or peripheral fire breaks. We are opening a place or an area without vegetation, and with these simulations through these porous media, you can see that more or less when the sides of the vegetation in the windward is less than the size of the vegetation, the height of the vegetation, the leadward, you can have this more or less this positive rotor bringing down the flames, the air, and the firebrands. While if we have some pruning in the lower part, you have this positive rotor bringing up the flames on the and you can apply exactly the same for the design of the different plots. Here's another example. We have a very, very important perimeter fire break, big one, but the problem is that the winds here are aligning from west to east and the southwest to northeast, which are the most important. So when we have these two type of winds coming from the west or the southwest, the wind can find these openings and accelerate more than in the place where you have the places where you have no openings at all. So you can expect some, let's say, more efficient flow of air exactly in the place that you are trying to reduce the intensity of the fire. Here's the opening, and you can see the effect aligned to the wind because it's a saddle and the x-axis of the fire break is exactly following that. And that's very important in our designs and our mitigation strategies. We have to think about the wind, the effect of the aerodynamics. Look at this in Ibiza. We have here a treatment, a mitigation treatment in the understory. You can see the trees, but under the trees, there's almost nothing. It is quite effective. If you have the strong winds, for sure that the fire will jump from one crown to the other and impact in the houses. But the point is that we have to look into what are the winds prevailing in this area. The winds are coming mostly from the southeast to the southwest. So you can expect here, this is a head fire is coming towards the community. It will come downslope, so it will be a lower intensity than expected. And these northern winds are not so frequent. The most frequent are coming from the south, the southeast, or southwest, which will bring us an incipient fire right flank hitting the houses or the backfire going downslope towards the houses, which is why this structure is so interesting for this combination of fires, slopes, and winds. So our properties should be adapted as well. You can see here very clearly that we have walls separating the properties, which are extremely interesting when we have these treatments behind your properties. The treatments, the walls are my property without any green edges and very few fields inside. This is a fantastic strategy for the protection of a wetland interface case. Some of the strategies is to create a progressive mitigation of the fuels, but also inside the first rank of the properties, and whether possible to encircle all the properties with the surrounding roads. In this case, we have some houses detached from the perimeter road. They are extremely exposed to the incoming fire. To end my presentation, I will look into the interior, which is perhaps the most challenging because we have to combine, try to orchestrate all the properties that we have inside a settlement, taking into account how our fires behave in our settlements. They come through the settlement, but when they reach the settlement, they start jumping through embers and affecting non-developed lots and all these linear structures, which are green edges connecting several properties at a time. And that's very interesting that one fire, which is hitting the left flank in this case, is jumping through this combination of embers, undeveloped lots, and green edges up to 2 kilometers inside the urban area. It's very relevant that all these non-developed lots are very efficient in creating high-intensity fires, affecting the edges and propagating the fire through the edges inside the settlement and then hitting the houses. So the green edges are part of the very important part of our, let's say, strategy in mitigating the propagation of the fires inside, particularly all these highly flammable and combustible green edges that we have in our latitudes. You can see how efficiently propagate the fire. Something that we have observed in WUIVIEW project, something that was to me very shocking, is to realize that these green edges of compressors and so are very efficient burning. They provide a dose of heat, but they are very quick. So they are, in the end, they are not a continuous source of heat which is affecting the house. It is very fast and is very efficient in transferring the fire from one point to the other, as we have seen in some of the cases that we have suffered these very years. You can see here how efficiently a flanking fire is affecting our green edges in a urban area and catching another vegetation and affecting the structures. Here you can see it's something that we studied and sampled in detail in the WUIVIEW project. Here you can see one of these vegetation structures, the green edge, and this axis is perfectly aligned with the prevailing winds in the day of the fire. So you can see this high intensity fire when you have this lining of the winds with the axis of the edge, then creating this high energy release and the effect on the surrounding buildings. As we can see here, and in some of the structure, you can see the effects of radiation on this canvas. There are another structures of edges that we have studied in WUIVIEW, which are not so efficient in transferring the fire, like this type of Aerodynamics or Nedunoleander or Buxus and Perviriens. So another message I would like to set out in this webinar is that we have to start to learn and educate our eye to see and read the landscape in the interior of our settlements, and which is the role of our property in the creation of this continuity and continuous patterns, the alignments with the winds, the vulnerability of the houses to the wind directions, and the estimation of the penetration of the fire inside the settlement, which is why here you can see that there's not too much forest vegetation, but it's a lot of different edges, which are, you can see the vegetation map. You can see here the lining of the different edges with the prevailing winds, which are coming from the southwest or the west. So you can expect here some very efficient propagation through these different structures of vegetation. Together with that, we have inside of the settlement, this continuous plots of lands of vegetation, which is not exactly forested land, but it is providing you locally some fire runs, which eventually can hit if the house is inside. Given that it is inside the settlement, you can see the settlement. There's no separation between these internal plots of land full of vegetation, and so we can expect this impact on these properties. It is something that we have to understand, that our property, as you can see here with these edges, will contribute to this continuity of the incoming fire jumping into the edges and running through the edges to the different properties one after the other. So as I was telling, is that the strategy of the reduction of the continuity due to the green edges, which are very efficient transfer the fire, should be included in the design of the community and in the reduction of the risk in the property. Here you have some simulations of fire running through a more or less urban area, which is very efficient when it finds these line alignments of vegetation, plots of lands in one wind and the other. The same in other study case that we have in WUIVIEW, which is in Valencia. You can read that there's a very short run towards this set of towers of buildings, very short run here, but quite a long run from the beach, this is the sea, towards the buildings. So the same happens with the south winds. Here we have the simulations. With west winds, which are very dry, very dangerous winds, the run of the fire will be very short after the fire front is finding some buildings. So we have a short run before it's hitting the buildings. But when we have these east winds, this quite different because the fire will reach the houses consolidated. But when we have these south winds, the left flank will reduce the intensity and the speed because there's no fuels in these properties or these lots, while the right flank will continue with high intensity hitting the properties in the north. So these lineups and this continuity of vegetation is affecting the way we understand our settlements. Here you have another example in Mallorca Island. We have these alignments, the continuity inside the settlement. So in the micro scale, we have to think about the micro scale, the defensible space, which is 30 meters around the house, as part of several properties. It is not just the management of one property. We have to deal with it and try to get to an agreement with your neighbors and create this defensible space as a common space, which is of benefiting all of them. Today, we have not observed nothing like that. The importance of the gardens that we have been studied is not only the species on the fields that we find inside, which are not vegetable ones. The vegetable fields which are more affecting a garden are the fine dead fields, and sometimes they are hidden in the structures of the vegetation. The good part of the gardens is that the moisture content of the live part of the plants can be controlled because it is subject to irrigations. So the moisture content of this pine outside the settlement is totally different to a pine or another vegetation which is inside. So we have more water, we have more protection for the wind, but we have more, let's say, a more exotic type of fields, more particularly where you have this dead field distribution. So our strategy here is try to break this continuity in the fire load, particularly with these load of fine fields and promoting the green parts, but at the same time protecting the soil and incorporating the water into our different plants which are more resistant to the fire. That is a good part of green gardens, because the green gardens and all the design of the gardens can contribute significantly to the protection of the whole community. It's not just a matter of protecting your house, separating the fuels and trying to remove the fine fuels, but preventing the fire to propagate through the edges by selecting different type of species which are less fire prone or with more water content, and hence protecting the houses, the property, and the community as a whole. You have seen that these, in the property level, the edges are of a specific importance because this sometimes the only the fire load that we will find, and at the same time to provide not only the discontinuity of the different ornamental species, but also provide some elements for self-protection. Self-protection is a word that we will use more and more as the time is coming, as we are facing this type of fires, overwhelming firefighting response. Here you can see a very clear sample of at the property level in the fire of Rognac in 2016, in which we have one owner which is preparing the lot with this lawn, with some irrigation, almost no fields, protected houses, while in the other hand you have this other neighbor with a lot of different objects on the vegetation near to the house, and so one is conditioned the safety of the other. So we can come down to these different objects and materials that we have studied more in detail in the WUIVIEW project, and the importance of these objects and materials inside our property as a main driving factor for the destruction of our house, more particularly those which are close to the house, as in this case in 2016. We have plenty of different objects and materials burning within the property and affecting by this fire load to the house and destroying it. Here's another case, very extreme case, in which a very low intensity fire coming from the west part was running in Buger, in Mallorca Island, jumping and entering a lot where were thousands of objects and materials, and all of these thousands of objects and materials pile up over the years, burn all at a sudden, and created a big fire load, and obviously destroying the different buildings inside. The same for this property, which have almost no vegetation at all, because it was a grass fire mostly. But once the grass is rich in this property, which is with several vehicles and many objects inside that was before the fire, it creates a local fire load which is affecting the property. Clearly, the firefighters would not try to do much with this type of fuels burning at a time, because it's quite dangerous. There are many exotic materials and objects burning. So more or less, you have to confine all this situation and then expect the best, pray for the best, because the house is exposed to very high dose of heat. We have many of these cases in which the surrounding materials and objects are more important than whatever you do in your garden with the ornamental vegetation. So basically, it's the edges and the objects and materials that we have around what we call the residential materials. Particularly, they are located in semi-confined space, semi-enclosed space like this very enclosed, let's say, terrace. In this case, you can see accumulation of heat on the affection of the houses, and sometimes the destruction, as in these cases. On the same, that's just touching the skin of the building, of the house, when we are talking about the fields on top of the house, not near, but on top of the house. And this is part of our strategy to prevent fires affecting houses, more particularly this accumulation of pine needles on the rooftops, on some of the buildings that we have side to the houses. I will end my presentation just by giving some very brief reference to the fact that if we change the vegetation inside, and sometimes it's not as important as the edges or the objects that we have seen in real cases. If you are changing the distribution type heights of the different ornamental species, trees and so, you're actually changing the way that the air is behaving around the house, particularly in two aspects. The first is the air through porous media is behaving quite nicely when this porous media is letting the air pass through partially. So if there's no, let's say, vegetation or protection, you can see this typical rotors forming, negative rotors in the pores and in the terrace, and a positive one in the pores. And so when we circulate this porous vegetation, according to the distribution of the tree branches, and particularly if you prune the tree, you let the part of the air to go through and reducing the speed of the air, but at the same time you prune it, you create this acceleration of air, and these positive rotors increase. If you put some other elements like walls, you are deflecting the air flow. But the point here is not just the air itself, because in a forest fire, it is almost evident that there will be a turbulent wind regime. Is the fact that if we are reducing the wind speed, we are creating corners and places where the debris is accumulating over time. And in case of a fire, the firebrands will accumulate in the same places, finding all these debris and creating potential ignitions. To finalize that, because I'm out of time, it's just to let you know that with all these that we have at hand, we have to provide a plot assessment. We have created within the WUIVIEW project a very interesting schema of how to proceed with this assessment of the risk within a plot, and more particularly the risk for the building. But in the lower part, you can see as a driving factors for the risk of the structure, there reads poorly managed settlement, a poorly managed property. So you can see that there are two main factors which has to do with the planning and the maintenance of the garden and the property, which leads into the destruction of the houses, which is why we have to proceed with this maintenance of our plot and the neighbors as well, to create these defensible spaces of different kinds. You can see here the defensible space. In the same area, you have a non-defensible space, but there's no treatment at all. Here you can see a very interesting case in which the lower part of the tree stand, the pine stand, is literally covered by buildings. That means that in case of a surface fire, the fire will not progress through it. For example, a flank fire, a backfire. But in case of a strong wind on a crown fire, the fire will pass through the crowns from one to the other. So as I told in the first part of this presentation, it depends on the intensity of the fire we are expecting, which is why it's so interesting that we prepare the exterior of the settlement to receive the fire of a certain intensity. So we can then proceed to the design of our properties in a more, let's say, efficient way. Some of other different examples of plot assessment. This is quite interesting. We have, and I'm finishing my presentation, very strong buildings. This is a rural area, which are subject to potentially low intensity fast fire. But the point and the problem is that our design should include the presence of residential fields around us in this case. That's my last slide, in which I will suggest that all this assessment of plots and modeling and planning should be a geo-reference in a map. So to have an idea of which is the vulnerability of each of the plots in regard to the property, but also in regard to the community as a whole. And I hope that this presentation has made you some reflection and some thoughts about that, and I'm ready to take some questions.
Thank you, David, for your presentation. It clearly shows your intense activity either in doing field work, analyzing aftermath of fires and prevention planning during your activity, as well as your simulation work. So thanks very much for your presentation. There's quite an active discussion here in our chat, in our YouTube chat. I'll try to summarize a little bit the different questions and comments and topics that have been highlighted. I would like to start trying to translate to you the questions about the management of the properties, particularly at the perimeter, right? There are some questions related to the role of the homeowners, how you think homeowners must be persuaded, how effective should be the messages to homeowners, and what do you think it is the best technique to do so? And also regarding this same topic, how to manage the properties, particularly at the very perimeter. What's the role now of firefighters? What do you think firefighters are involved in this role of management of the properties, firefighters or fire prevention agencies? Meaning, in summary, what are we doing now in terms of population awareness and prevention of those types of properties?
Well, quite interesting questions indeed. The role of homeowners, that's to me, it's paramount. Perhaps the most important of all, because we have thousands of homeowners. We have some communities, some municipalities, and so in some regions, but we have thousands of homeowners. So if we consider homeowners as an active asset for prevention, it's a huge army of preventative actions that could be done. So the idea is that the people perhaps are aware about the forest fire risk, but they assume a trade-off of, well, I prefer this type of vegetation to be isolated from my neighbors, to have some shadow, to protect myself from the wind. And my trade-off is that in case of a fire, I know this will not be defensible space. So you have to warn him or her that the condition of the protection of the house is quite difficult in this case, and try to get to an agreement, to a compromise solution. Well, if you retire these little things, perhaps you increase the likelihood of protection by 30% or 50% or 100%. So it's a matter, first of all, of understanding why people do things, because the people take decisions for some reason. Try to find a compromise. Well, if you change this type of edge for this other, you more or less are covering your needs, but you are reducing the risk of losing your house by 80%. In this case, the role of firefighters are also of paramount importance, because firefighters know what works and what doesn't work. Besides, they are a clear view of they are the responders of in these emergencies, so they are respected and their word are listened. So if the firefighters tell them, well, in case of a fire, I cannot defend this, not me, I'm just an engineer. No, a firefighter is facing this reality. I'm talking to you. I've been operating this type of houses for many years. If you do not change this, I cannot ensure that it will protect your house and yourself. And here I am to help you in changing a number of things. So it's a critical force to be used for the prevention.
Mm-hmm. Let's move on to more specific subjects related to the management of the properties, and let's move on to talking about vegetation, right? There is a question related to the green hedges. The question is would you propose banning green hedges of particularly flammable species? This question to me makes sense because, it is already pretty much known what are the worst species in terms of flammability. So do you think that we should be coming up with some sort of legislation or guidelines just to ban particular species?
Well, no, literally no. I presented some positive aspects of the edges and the vegetation. It is protection against wind. You have the house is supposed to wind the whole year round, and to a forest fire maybe once or twice in your life. There are many benefits of green edges on the ornamental vegetation. For example, the coverage of the soil, the creating of this shadow area is creating more moisty gardens, so it's eventually more protected for the pass of the fire. So it's a matter of finding the best design, the selection between the species which are more resistant to the pass of the fire, with less flammable materials or flammable components, with less amount of fine dead fuel, and create these environments which are, let's say, less fire prone. The problem with the flammable green edges, they have many benefits. They are very cheap, easy to treat. They grow very fast and they smell well, but the problem is they are like a fuse, transferring very effectively fire from one point to the other. All the owners that suffer a fire in one of these flammable edges, all of them concluded, I will change this type of edge immediately because I know now what you're talking about. So it's not a matter of ban, but redesign the gardens towards a more resistant structures of vegetation.
Mm-hmm. Regarding vegetation, there's still one question about fire tests. We at the WUIVIEW project, we've been performing fire tests in ADAI premises in Coimbra, and the question is about the standardized fire tests. If there are any standardized fire tests for vegetation that allow classification of vegetation species to determine its risk level. Would you like to comment on fire tests regarding ornamental residential vegetation?
Yeah, that's very relevant indeed. The point is that the fire tests are needed to have a a clear understanding of how these edges burn, how fast and how much heat they provide. The point is that what we find in the real world are structures that are very difficult to mimic in the laboratory, more particularly when you are pruning for 10, 12 years an edge. It's creating inside a load of fine fuel, which is very difficult to obtain in the laboratory. In the laboratory, we're working with particles or test with the particle level or with individual trees or plants, which to some extent give you an idea. But to me, it's very important to understand that all the structure of these edges, which create a unique solid mass of vegetation with all this dead and live material. And when you are clipping the edges, you are creating the plants to bleed some, let's say, flammable fumes and different type of fuels, which will help to these structures to be more flammable. So in the future should be real edges in the real world and then burn them under controlled conditions. Otherwise, we have very little insight of the real fire in the edges. It's difficult, but really needed.
That's true. That's true. We have been experiencing all those challenges in our WUIVIEW fire tests. Let's move on now to the building side, right? We have been commenting on the vegetation. Let's focus now on the building. We have been studying within the WUIVIEW project several building vulnerabilities, and also you have mentioned some of those. We have worked with and studied different types of materials or different types of geometries that might be vulnerable, like semi-confined spaces and so on. So you've been mentioning some vulnerabilities regarding the building. We have a question here. Just let me try to find it. Yes, now I've got it. It's about technical building code. The question is should we have a technical building code specifically focused on the WUI, for instance, banning roof shapes that are prone to accumulate firebrands or banning particular materials, so on stuff? Do we need a technical building code here in Europe and a specific European building code to cover our reality?
That's very true. That's very much needed. The point is that we have quite a lot of work done with all these energy efficiency preparation and codes. Most of the strategies, materials, and building methods aim at creating more energy efficient buildings, are helping us to protect the houses against the external source of heat or the firebrands or the smoke. That could be a fantastic starting point, but just adding a little more about this resistance of the different parts of the house skin on the geometries as you mentioned, where you have accumulation of not only the debris, but also the firebrands, the heat and everything. To me, it's quite easy to do so, but we need some more, let's say, laboratory experiments, more essays. The other point is that I didn't focus in this presentation on the building. I realized I focused on the surroundings of the buildings, on the property as let's say the garden and surroundings of the building. But it is true that there are many other vulnerabilities which are not directly related to the materials building methods, but to the good practices, like opening a window in a forest fire. Let the window open makes any type of building vulnerable to firebrands, well, and not using shutters in the screen and the windows and so on. So it's a compound not only of technical aspects of materials or building methods, but as well as good practices before and within the forest fire emergency.
Right, we still have 5 minutes to comment 3 more questions that are in our chat. They are, let's say, tangential topics, sort of, but I guess that they are quite interesting to highlight those and to comment a little bit on those, because they are really related to the work that we've been doing in the WUIVIEW project. The first one deals with the fire protection and active protection systems in WUI properties. So the question is as follows: apart from the fuel and landscape management that you talked about, what is your opinion on passive and active protection systems for lowering the risk of a fire endangering the WUI structures?
That's very, very interesting. To me, the most interesting thing about that is passive approaches, more particularly that has to do with the roofing and the glazing. Two very important things to reinforce the structure to resist this. Anything that we can do to lower the intensity of the fire surrounding the house, more particularly the heat sources close to the house, it's a good approach. But think about this. We have a very intense fire coming to the house. We didn't do any management of heat, so it's just, I don't know, 80, 100 kilowatt per square meter of radiant heat, let's say, or something very big. What can I do in terms of active systems? Put water to that. Makes no sense. If you do not reduce the intensity of the fire, more particularly the intensity of the fire close to the house, to me, the only, let's say, reasonable way of protecting the house is reinforcing the house to resist this heat amount of this heat dose. For lower to mid or to meet low to mid intensity fires, these protection systems work well to, let's say, reduce this intensity. On the other hand, we have the fire brands. Fire brands are a big problem, particularly in those places where accumulated debris and the fire brands. Just the sprinkler systems moistening all the debris and whatever materials that we have there reduces the likelihood of a fire brand to start the fire near the house and then catching up into the residential fuels on the house. So the answer is yes, that makes sense, but coupled with the reducing of the intensity of the fire, or thinking about protecting against the fire brand shower.
Right. Okay. And another tangential topic which has been highlighted here in our chat is about the wildland industrial interface. We haven't really studied that in the WUIVIEW project, but there is a question here which is as follows: have you studied the effects of wildfires on the wildland industrial interface? Have you seen any cases of wildfires affecting industrial sites?
Well, myself, actually, no. I have some references, but actually, no. What we have instead is the forest fires affecting critical infrastructure, which is similar, but it is not exactly the same. Industrial installations or industrial places are considered, let's say, critical in the sense that in some cases the materials or the machinery, installations, or whatever it's in there, affected by the rate of the incoming fire exposed to the heat, could develop another emergency inside the emergency. Let's say toxic gases, explosions, or the other type burning of other exotic materials. Other than that, there's no other difference. So my consideration about industrial areas is that as far as they are critical places which could lead into an emergency inside the emergency, a domino effect, or that these installations are critical for the management of the fire event, like electric power supply or communications or things like that.
All right. So just let me take two more questions. It's 5 o'clock now, but I guess that it's kind of interesting to take the last questions of that webinar. One of the questions deals with climate change. So it's a broad topic, but of course, fires has lots to do with climate change. And the question is as follows: fire mitigation measures are based in our current experience, but climate change will set new challenges. Is prevention planning by itself enough to cope with these new challenges and fires?
No, the answer is obviously it's not. Obviously, there were some driving factors like these long and intense drought periods, which are affecting the moisture of the life plants. What we have today, that clearly it's evolving. In many places, when we have a forest fire, not a wildland-urban interface fire, a forest fire, under these extreme severe drought periods, that vegetation would never recover back again. And a new structure, a new vegetation, or no vegetation at all, will be replacing this land. So I absolutely agree with our colleague on that we should look first of all on the water availability, which is one of my concerns. That if we want to protect the wildland-urban interface under water scarcity scenarios, that will be really difficult, and they will lead to reinforce the houses and reduce the vegetation presence. In this line, may I make a remark on the importance of water reclamation and use of treated waters for creating more resistant areas surrounding the communities and maintaining the gardens to protect people. Other than that, if climate change is clearly telling us, well, under these severe conditions, extreme weather and extreme fires, you will be in danger, it is better to move on to other place. If you have no way of protecting yourself, please move to other place. So I absolutely agree, we have to reconsider this question very, very seriously.
Excellent, David. Let me take two more comments that are in the chat. I wouldn't like to leave those comments unattended. Those are comments regarding the discussion that we just had about vegetation, about green hedges, about banning species or not banning species. And the comment is as follows. Comment from California. They say that the concept of what plants are allowed or not allowed near a building is something we are struggling with in California. We have investigated small and large testing, but it is very complicated. So that was a comment from California. And then there is another suggestion of how to deal with this problem of all the vegetation and surrounding buildings. The suggestion is as follows. Is vegetation mapping around a building and track the vegetation and plant growth around it? That would be helpful.
I didn't understand you. Could you please repeat?
Sure. So there was a comment from California about
the first one was okay, but the question I didn't catch it.
And the second one, and the question is vegetation mapping around a building and tracking the vegetation and plant growth around a helpful solution?
Well, that's a tricky question. In our experience, our colleague is pointing out a very important issue, is that the fuels touching or near the house are the more important to protect the house, because it will be in the end the real exposure, more particularly the vegetation touching the house. Look, in Europe, our houses are mostly unburnable, but they burn. So we have to focus on the vulnerable parts of the buildings, which are more exposed to the closer heat sources. And what you say, mapping the vegetation at this scale should entail a very detailed three-dimensional mapping of the fuel load, because we are talking about the structure of the fuel load and the structure of the moisture distribution. And all this happens in 3D. So to be really, really precise, you have to map the fuel load, more particularly the dead fuel load, that's difficult, and to map the moisture content. Sometimes the moisture content in the garden is higher in the lower parts than the upper parts. So it's very exciting. We have some techniques to do so. We did some modeling with detailed photogrammetry using drones, which is quite cheap and quite efficient, or a ground LiDAR. But even though the question is, how costly are these methods to apply to regular normal houses? That makes sense for critical infrastructures, which has to be studied in very detail, or for scientific research. The answer is yes.
All right, it's 5 p.m. now, or it's 5 minutes past 5 p.m. So it's about time to close this session. Thank you all for all your questions and comments. And again, thanks David for sharing all your knowledge and experience with all of us. Please stay tuned, and I hope that we can reach you all next week, next Wednesday, again at 4 p.m. And this time it's going to be Pascal Baca from Technical University of Catalonia, who will be talking about the methods of analysis of fire behavior impacting structures that we have been developing using CFD within the WUIVIEW project. Thank you all. Take care and